Welcome there, Mr. Sutton here with the Pre-Cal Honors 3-6 Part 1 homework solutions on features of rational functions.
For number 1, we're trying to figure out the key features of this rational function. I'm going to start by factoring things out here. All I can really do with factoring is my denominator. I can take out a 2, leaving me with x minus 2 inside. And now that I've got factored out, let's pick out some of these key features. So for the x-intercepts, that's whatever makes the numerator 0. So we have x plus 1 equaling 0. And we're talking about the numerator because that makes the whole function 0. The x-intercepts are just the zeros of our function. So we have an x-intercept then at x equals negative 1. And since this does not also make the denominator 0, then we don't have to worry about it being a whole or anything like that. All right, let's talk about y-intercepts. So that is where x equals 0. So I'm going to plug x in for 0 in the original function here. That's going to zero out anything that has an x, leaving us with just negative 1 over 4. Next, let's talk about vertical asymptotes and holes if there are any. Since we don't have any duplicate factors, there are no holes on this one, but we can set our denominator equal to 0, our simplified denominator equal to 0, and that'll tell us the vertical asymptotes. So we have a vertical asymptote then at x equals 2. And then finally, for the horizontal asymptotes, looking at the degrees of the numerator and denominator, it's the same degree. These are both x to the first power as the highest exponent term. So that means we're just going to take the lead coefficients, the ratio between those, and that'll be our horizontal asymptote. So we then have y equals the invisible 1 here over 2. For number 2, I'm trying to find intercepts, asymptotes, and holes for this rational function. Let's begin by factoring that denominator so we can see what we're dealing with. Two things that multiply to negative 6 and add up to negative 1. That would be x plus 2 and x minus 3 for that denominator. And now let's go through and find these different features. So for the x-intercepts, I want to zero out the whole function, but all I need to do for that is zeroing out the numerator. So we'll have, for the x-intercepts, x minus 1 equaling 0. So x equals 1 is the only x-intercept for this graph. For the y-intercepts, let's plug in 0 for all the x's in this original function. So we've got, when the dust settles, anything with an x is gone. So that's just going to be negative 1 over negative 6, which is positive 1 over 6. And then let's find vertical asymptotes. Since nothing is going to cancel out, there are no holes here. It's just whatever zeroes out this simplified denominator is going to be a vertical asymptote. So we've got x plus 2 times x minus 3 equals 0. So x equals negative 2 and x equals positive 3 are the two vertical asymptotes for this. And then finally, for the horizontal asymptotes, looking at the degrees, I have a bottom-heavy function. We have an x squared on the bottom versus just an x to the first on top. So the horizontal asymptote is automatically going to be x equal or y equals 0. And that's because as we get larger and larger and larger numbers being plugged in, the bottom is growing a lot faster than the numerator, meaning this whole fraction is shrinking to 0. For number 3, let me find all the intercepts, asymptotes, and holes for this rational expression. Before we go any further, let's factor this out as much as we can and simplify it if possible. So I can start by taking an x out of the numerator. That'll leave me with 2x squared plus x minus 3. And then denominator, I can factor that into x plus 1 and x minus 1. For the numerator, I have to split this up into two parentheses. In one of them, we're going to have a 2x. The other needs an x to get this 2x squared. And then we need some combination of 1s and 3s, and one of those has got to be negative. So I'm going to make a guess, and then we'll check to see if I guessed correctly. So here's my denominator being factored. And now I'm going to guess 2x plus 3 and x minus 1, because 2x times x is 2x squared, and 3 times negative 1 is negative 3. But now let me check the outers and inners. 2x times negative 1 is negative 2x. 3 times x is 3x. Negative 2x and 3x does add up to positive 1x. So, hey, looks like I guessed correctly on the very first try. Boy, I'm lucky. Okay, let's keep going. X minus 1s can cancel, leaving us with just x parentheses 2x plus 3 over x plus 1. Now that I've canceled out those common factors, let me go ahead and find my x-intercepts. You want to make sure you do this before finding the x-intercepts, because the x-intercepts, to find those, we're going to set the numerator equal to 0, just to figure out what zeroes out the whole function. But when I do this, I only want things that make the numerator 0, not things that also make the denominator 0. And if you have these common factors, you're going to find a little bit of both. So using this simplified numerator, I get x equals 0 and negative 3 over 2. Now let me find my y-intercepts. For this, I'm just going to plug 0 into the original expression here. So plugging 0 into all of those x's, the entire numerator gets zeroed out, and the denominator is something other than 0, so we end up with 0 for that whole thing then. And actually, come to think of it, if you have an x-intercept at x equals 0, that's at the origin, right? So that's also a y-intercept. So it makes sense that we would have 0 for both of those. Moving on now, let's find all the asymptotes and holes, if any. For the vertical asymptotes, we're going to set the simplified denominator equal to 0. These are things that still make the denominator 0 even after we canceled out other stuff. So we have x plus 1 equals 0. That means we have a vertical asymptote at x equals negative 1. And now for holes, those are going to be things that would have zeroed out the denominator, but we canceled out, so they're no longer in the simplified form here. They've been removed. So we just have x minus 1 equaling 0. So we then have a hole at x equals positive 1. Now with holes, remember, there's a y value that goes with them. But for our purposes, we're just listing the x value of the hole. Keep in mind, though, this is not an asymptote. This is just a point of discontinuity. Okay, moving on to the horizontal asymptotes. Since we have a top-heavy function, that means we have no horizontal asymptotes. This thing is just going to keep growing and growing and growing without bound. However, that doesn't mean there's no pattern, so we instead have a slant asymptote. So to figure out the slant asymptote, we have to divide the numerator by the denominator. To do this, I'm going to re-simplify my numerator into 2x squared plus 3x, and now I'm dividing that by x plus 1. I can do this pretty quickly with synthetic division. So I'm going to set up my coefficients of 2. We have 3 for the x term and 0 for the constant. I'm going to have a box number of whatever zeroes out the divisor, in this case negative 1. So we bring down the 2, times negative 1 is negative 2, plus 3 is 1, times negative 1 is negative 1, and then we have negative 1 for the remainder. Now all we really care about is this quotient here, which is going to be linear. This is going to be y equals 2x plus 1, and that will be our slant asymptote. For number 4, we're trying to find intercepts, asymptotes, and holes for this rational function. Let's start by factoring this as much as we can. Right away, I notice I can take out a common factor from the numerator and denominator. I can take an x out of each. Up top, that leaves me with x squared minus 9 inside and x minus 4 from my denominator. I can then cancel out those x's. And factoring things a little further, I've got an x plus 3 and an x minus 3 up top, and still an x minus 4 on the bottom. Okay, so let's find the x-intercepts. We're going to set the numerator, the simplified numerator, equal to 0. So that gives us negative and positive 3. And again, we're using the numerator that's been simplified. If we use the original numerator, then we would have also ended up saying x equals 0, but that zeroes out the denominator as well, which is no good. We'll talk about that a little more in just a sec. So for the y-intercepts, we're going to plug 0 in for all the x's in the beginning. That gives us a 0 up top and a 0 in the denominator. That's a problem, right? This is not defined. So that means that we don't have a y-intercept. Another way of thinking about it, and we're going to talk about this in a minute, is we actually have a hole that's on the y-axis. Let's continue by finding the asymptotes and holes, if any, for this function. So for vertical asymptotes, we're just setting anything left in the final denominator equal to 0. And whatever zeroes out that last denominator there is going to give us a vertical asymptote. So that's x equals 4 in this case. For holes, we're just setting whatever got canceled out and is no longer in the denominator equal to 0. That's just x in this case, so we can say we have a hole at x equals 0. And then for the horizontal asymptote, we're looking at our degrees. This is a top-heavy function, so it has no horizontal asymptote, but a slant asymptote instead. So then we're going to divide the numerator by the denominator. I'm going to use this version of it over here, because this is something that's pretty easy to use synthetic division on. So let's set up our synthetic division. Our first coefficient is a 1, followed by a 0 because there's no x term, and then a -9 for that constant. My box number will be whatever zeroes out this divisor, so 4 in this case. Bring down the 1, times 4 is 4, plus 0 is 4, times 4 is 16, plus -9 is, we don't care, but we'll put it in there, 7. So now we just need the quotient here, everything except the remainder, to give us that slant asymptote. So we're going to have y equals 1x plus 4. For number 5, we're trying to find key features of this rational function. Let's start by factoring it as much as we can. Top factors into x plus 3 and x minus 3. For the bottom, I need two things that multiply to -3 and add up to -2. That would be x plus 1 and x minus 3. These x minus 3's are going to cancel, so our simplified version of this function is just x plus 3 over x plus 1. So let's go ahead and find the x-intercepts based off of that. We're just going to use the simplified numerator for this so that we're not including wholes along with x-intercepts. So we've got x plus 3 equals 0, so then an x-intercept at x equals -3. For the y-intercept, we're going to plug 0 into the original function, so that'll be just 0 squared minus 9, and then we've got 0, 0 minus 3. That all comes out to -9 over -3, which reduces to just positive 3. Now let's take a look at asymptotes and wholes. So for vertical asymptotes, we're just looking at the simplified denominator and seeing what zeroes it out. So x plus 1 equals 0, giving us a vertical asymptote at x equals -1. And then for the wholes, any factors that got canceled out and are no longer in the simplified numerator or simplified denominator, those are, when you zero those out, those give you wholes. So for our wholes, we'll figure out what makes x minus 3 equal 0. And if you add 3 and solve that, we find that we have a hole at x equals 3. And there's a y value that goes along with it too, which you could find if you plugged this back into the simplified function. We're not going to do that though. And now, we also want to talk about horizontal asymptotes. This is a same degree function. We have an x squared on the top and the bottom. So we just take the lead coefficients, that would be 1 over 1, which gives us a horizontal asymptote of y equals 1.